Hey, it's Ivan again. I'm a solution architect at Harper, and I do these Friday episodes to take you through the things that I'm learning so that you can learn along with me. Harper has built a really cool composable application platform, and it's versatile and useful in many situations. So as I've onboarded at the company and learned how to use the platform and talk to customers about their problems, I like to share these weekly videos to show you what I've learned about our platform and how it might help you. So sit back, grab a cold beverage, and let's talk about MQTT. What is MQTT? MQTT is the message queuing telemetry transport protocol, and it is a standard supported by the Oasis Foundation and supported by MQTT.org. You can see I open the browser here, show a little bit about what MQTT is and what it comes from. It's been around for a long time, used in the Internet of Things. I've used it in previous roles at previous companies, building IoT solutions end to end with the cloud, remotely connected, intermittently connected. It's pretty robust, pretty common, pretty popular, and everyone seems to know how to use it and why to use it. It's extremely lightweight for the client, which is one of the reasons why MQTT is so popular in the Internet of Things, where you have very small clients doing things in very remote places. So it kind of took off there. It's having a little bit of a resurgence in looking at AI operations when you want to do AI at the edge, using MQTT as a thin shim to queue and transmit that and transport that telemetry back from the edge to your data center, your infrastructure for doing AI ops, model training, and that stuff. So that's what MQTT is, and that's where it comes from. Now, how does it work? I'm going to scroll down here and I'll show you. MQTT is really made up of two parts, a broker and clients. A broker is, just as the name implies, a central point for where clients can publish content and clients can subscribe to content. So it's a pub sub or publish and subscribe pattern implemented using a broker and client software and a bunch of little bits of software to do it. Now, what are the things that they publish and subscribe? In MQTT, they're referred to as topics. So if you look at this example here on the screen, you can see we've got a temperature sensor, a thermometer, and it is an MQTT client, and it's going to publish its temperature. It's going to publish to the topic temperature. The broker is going to capture that and make it available to subscribers. And those subscribers are also clients. They could be mobile devices, other devices, web pages, processes on servers, any number of things. And they will subscribe to the temperature topic, and then they will get, when the thermometer publishes temperatures, the temperatures delivered to them because they're subscribers. That's how MQTT works. It's pretty straightforward and pretty simple. Now, that's the standard stack, and that's the way things work. Now, let me take you through something that's really interesting about Harper. And the first question you might have, which I don't think I've talked about on any of these Friday sessions, is what is Harper? Harper is a 100 megabyte process that is what I call a microlith. And when I say microlith, I mean it takes the traditional service-oriented architecture where you may have separate services for database, messaging, caching, application hosting, and it puts it all in that 100 megabyte process. So in that 100 megabyte process, you have a database, you have a messaging layer, which includes MQTT natively, you have caching for performance, and then you have application hosting, all in one. And you get it by doing the install that I've taken you through in previous ones, where you use Node Version Manager, use version 24, and say npm install Harper, HarperDB. It installs, and then you get a command called Harper that you can just run, which I've showed you in previous weeks. I'm going to take you through the same process, but I'm going to show you a few things about what's in Harper that is native to MQTT. So over here on our docs, which are getting a huge revision soon, you can see, first of all, join Discord. You can talk to me about this or any other Harper related content you want. We're on Discord. But if you look at the developers section, real time, this is talking about real-time messaging within Harper. And one of the things that's within real-time messaging for Harper is MQTT. And it supports MQTT out of the box, batteries included, and it's enabled by default. You can see it's enabled on port 1883, which is the standard broker port. It's enabled on 8883, which is the standard secure broker port. It also enables WebSocket support. We have authentication is turned on by default, and we've turned MTLS off. Now, assuming you run Harper out of the box, the way it comes, you'll get that. Now, the question you have to wonder after that is, how do topics work in Harper's MQTT broker? Well, let me take you through a little example to show you how they work. First of all, here's my shell. I've got my terminal running. If I cd to where Harper installs itself, you'll see here's my stuff. And if I look at my Harper config, if I come down here, I'll get to the MQTT block. There it is. And everything that was in the documentation shows up there. It just works. It's just there. There you go. Now, if I cd back to where I was, which was projects, MQTT getting started, which you can see is in my thing here, and then I cd to the Harper directory, what I have here is the absolute most basic implementation of a MQTT system for a thermometer that you could implement. But if I ignore that, I go up here, one directory, and I just say Harper dev dot. It's going to run in this directory. Ooh, apparently I have one running. So I'll do that again. What I want to show you is you can see it is running on the MQTT ports right there. It is there and it is running. Now, if I come over here to Fabric and I look at my local instance and I log in with my handy dandy password, you'll see here I am. I'm in my local instance, and you can tell that because when I quit and I refresh, it's going to go, I don't know what happened, it all died. Great. So now I'm going to go down here to Harper, and I'm going to show you what's in here. So if I look here in my config.yaml, all I've got in here right now is a reference to my schema.graphql and my resources.js. And why do I have that? I have them in there because what I have in my schema.graphql is one table called sensors, and it records the location and the temperature from the publisher and an ID for the publisher. So that's in the table. And what I have in resources is a sensor resource. And what it does is when it gets a message, it does a write through the super, which is a table.sensors, that one we just looked at, and it'll send an alert if the temperature is over 100. Cool. Literally, it's those three things to create the temperature information. Now, I'm going to run the same thing we did here, Harper dev, Harper. If I can type dev dot, and you'll see boom, 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 cool, there we go. This is back now. And if I say admin, ABC, 1, 2, 3, and I get there and I close all these things. Now, there's my sensors table, and I've got nothing in it. This is where it gets really cool and why Harper is a lot easier and better than many things. So if I come over here, let me show you this publisher. And let me make this bigger so you can see what's going on in the publisher. You don't need to see that for a second. You only care about seeing this. So this is the whole publisher. I have a bunch of commented out stuff because I wanted to show more than one thing. But here's a publisher. This is going to publish the temperature on the Harper broker. So if I come over here to this window and I say node publisher, boom, published. I have a subscriber, and if I say node subscriber, you'll see it's listening. But there are no messages. There's nothing in Harper at the moment. There's nothing in our broker, right? Now watch. If I say publish again, all of a sudden this guy, the subscriber, got the temperature, but you didn't see anything in Harper. There's no new record in the table. Why? That's because over here in the client, in the publisher, in the publisher, which is a client, I have retain equal false. That means the broker doesn't hold messages. Everything is ephemeral. So it just passes through. And if it gets published from the client to the broker, and if there's no one to receive it, it gets thrown on the floor. But if there is someone to receive it, it gets handed off. So what happens if we turn retain to true? What happens if we do that? And then we come over here. We still have our subscriber running. Now, if we publish, it publishes. You see it comes through as the second message, and it shows up in the table because now it's retained. So Harper not only has the ability to do standard ephemeral messaging with MQTT the way it does normally, with retain set to false, it can retain those messages in a table, and you can look at them and see what's going on and see what's happening. And you can see here what the publisher is doing. Super simple again. It is doing a connect. So you got an MQTT client from a standard NPM MQTT package. We built a helper function to build a random temperature because we don't care in this demonstration. We've mapped this to sensor 101. So it's going to send it to the topic sensors 101. And we've just set the payload to being a random temperature in the location of the warehouse. So now when we do that publish, which is pushing it, if we have retained false, it goes to the broker, falls on the floor, and goes to subscribers. If we have retained true, it goes to the broker, goes to the subscribers, and gets saved in the table. Now, one of the other things that I can do is if I comment this out and I come down here, nope, that's not what I meant to do. I'm not going to do it in this session. I'll do it in the next session. But you can see down here, I've implemented the publisher to be able to loop every 5 seconds. It'll publish a new temperature so you can track real time and watch the data accumulate in the table. And this code will be available in a repo as well. We'll make it available when we publish the blog post that's going out today on how MQTT in Harper works and how MQTT in Harper compares with AWS IoT and how much simpler it is to use Harper to do it. And when I say simpler, I mean like go log into Fabric, build a free instance, boom, it's there. Now write your publishers and subscribers and you're good to go. Everything's done for you. On the subscriber side, a quick walkthrough of this code. It does the same thing. It imports the MQTT NPM package. It creates a client, points it at the broker endpoint. When it gets a connect, then we have the same topic, Sensors 101. We subscribe to that topic, and then we're listening for messages. We go into a listen loop. And all we do is we say, when we get a message, we decode it and we take the timestamp out. Well, we capture the timestamp when we got it, and then we say the temperature that we got in the payload and the location we got in the payload. And if it's not one, we just dump it as text because there was some broker confusion and we don't want to deal with that. There's an error handler. But then you can also see something really interesting here that I want to point out, which is there is a way to wildcard subscriptions to topics, and Harper's MQTT broker natively supports this as well. So you can imagine if you have sensors, you might have sensors 101, 102, 103, 104 ad nauseum. If you don't want to loop subscribing to every sensor, pardon me, you can do this, which is to subscribe to sensors /pound. When you do that, you subscribe to everything under sensors. Topics are a hierarchy, and so this is how you say, I want everything below this level of the hierarchy, and I want to subscribe to it all. All right, so that takes you through how Harper natively supports MQTT and what's going on, but let me show you something just a little bit surprising, and maybe not that surprising. So I've got a Python version of these tools. So you can see here's the Python version of the publisher. Same thing, it's doing the exact same thing. Here's a Python version of the subscriber doing the same thing. And you can see here's the same subscribe to sensor 101 versus subscribe to them all. But also there's a set of command line tools that can be used to test and build MQTT. And so here's a version of using the MQTTX command line tools with a shell script. And this is what it would look like. It looks like MQTTX publish, pub, the broker URL, the topic, the payload, and the QoS level, which is 1. There are like 3 QoS levels. If you look back over here, you can see reliable message delivering. So QoS level 0 is deliver the message at most once. So that's 0 or 1 time. QoS level 1 is at least once. So that's 1 or more times. And QoS level 2 is exactly once, which means once, not more, not less. And so these are standard sort of message queuing QoS levels that MQTT supports. But that's what this Q parameter is do it with Q. And you can see down here on the command line, if you want to retain, that is hold those messages in the Harper table, like I showed you in the JavaScript, you would say -- retain on the command line. And subscribe looks exactly the same. You would say MQTT subscribe, broker, topic, QoS, verbose, and I want the format in JSON. And then it's going to do a bunch of JSON parsing and printing it out with a shell script and using the JQ tool on the command line. But these are just alternative implementations of the same thing that we have in the Node.js code to show Harper is client agnostic. It's a protocol. And as long as you support the protocol, any tools written in any language will work with the broker. And Harper is a broker. That's all there is to it. Super easy, super fun. There's a lot about MQTT to dig into. We'll talk about PubSub in general and MQTT in the next few weeks. And I will talk about how MQTT, while legacy and awesome and historical and cool and great at doing the stuff that it does, might not be the technology that you want to move data from node to node, whether it's edge to cloud or edge to edge, when you've got native replication in Harper. So we'll dig into that in the future. Stay tuned. There's going to be some cool sessions around how native replication works. As soon as I learn how all the details are actually done, then I can share them with you. So thanks again to Kyle, who leads a lot of our development and engineering, Chris, who is our engineering leader inside the company, all the engineers in the organization who have built Harper and built such an amazing platform for us to work on and share and take to customers and show how meaningful we can make their business, accelerating their outcomes by providing them with this very cool microbit. It's kind of got my juices flowing. I'm thinking about what it means to create a movement around Harper and how we might actually inspire a radical change in the lives of developers by simplifying everything they have to build on, integrating it all into one thing, Harper. Kind of a cool idea, a little bit of a teaser. Maybe we're doing some stuff. Stay tuned. And don't forget, when you build with Harper, there's fast and there's Harper fast. So go to fabric.harper.fast, sign up, deploy your free instance, your free cluster, and start playing around with this and other code samples that you've seen either in our public repo on GitHub or on the Harper Learn channel you've seen yourself. That's it. See you next time. Thank you.